Hi everyone, we are from this group and today we will be presenting our project. First, we would like to introduce our team members. My name is Norik Mahaika bin Nisham. My number card matric is AA252158. And next is Afiq Saifullah bin Shamsul Ikmal, AA25042, followed by Nur Aina Batrisha binti Marin, AA25024. And for the last one, Nur Hanani binti Razali, AA25024. For today's presentation, we will be discussing our project, which is application of differentiation, which includes the background of the topic, the problem statement, our objective, and the main finding of our work. We hope our presentation will give a clear understanding of the topic. Without further delay, let us begin with the introduction to the topic. Thank you. Assalamualaikum and hi everyone. So for this session, I will explain the problem statement related to a vibrating beam in structural engineering. This study focused on the vertical displacement of a beam subject to dynamic loading condition. In real structural system, such vibration can occur due to moving loads, machinery, or environmental force. The displacement of the beam is modeled using a time-dependent trigonometric function given as a y bracket t equals t power 2 sine 2t, where t represents time in seconds. This mathematical model allows us to describe how the displacement varies with time during vibration. Differentiation is that apply the displacement function to determine the rate of change of displacement, which represents the vibration behavior of the beam at a specific moment. This approach helps engineers better understand the dynamic response of the structured elements under time-dependent loading. So next, I will explain the application of calculus in determining the highway curve radius. In highway engineering, the design of road curvature plays a significant role in engineering drivers' comfort and safety. The radius of horizontal curve affects vehicle motion and directly influence the level of comfort experienced by road user. In this study case, the comfort index of a car negotiating a curve is represented by the function C in bracket R equals 15R plus 2000 over R, where R represented the radius of the curve in meters. This function models in the relationship between the curve radius and the comfort level of the vehicle. By applying differentiation, the optimal values of the radius that maximize the comfort index can be determined. This demonstrates the use of calculus in solving optimization problems related to engineering design. In addition, plotting the function digitally allows for a clearer visual interpretation of the relationship between curve radius and comfort index, as well as identifying the maximum point. Overall, the section involves mathematical concepts such as differentiation of rational function, optimization using the first derivative, and graphitical analysis. So that's all from me. So I will briefly discuss explanation of mathematical method. Differentiation is the primary mathematical method used in the study to analyze engineering related function. It is applied to determine rates of change and to identify optimal values within the given models. In the vibrating beam case, the displacement function consists of a combination of algebra and trigonometric terms. The product rule is used to obtain the derivative of the function with respect to time. The resulting expression represents the instantaneous rate of change of displacement, which provide an indication of the beam's vibration behavior at the specific moment. In the highway curve radius case, differentiation is employed to solve of optimization problem. The first derivative of the comfort index function is calculated and equal to 0 to determine the critical point. This critical point represents the radius at which driving comfort is maximized. A graphical representation is used to support and verify the analytical result. Overall, the use is differentiation allows to the mathematical models to be analyzed systematically and support engineering interpretation and design decision. So thank you.
So hello, I'll be presenting the questions step by step, which consists of 2 applied calculus problems related to engineering. So the first problem focuses on a vibrating beam in structural engineering, and the second problem is about finding the optimal highway curve radius that maximizes driving comfort. I will explain each question step by step. So let's begin with question 5.1, vibrating beam in structural engineering. We are given the displacement of a vibrating beam as y of t equals t squared times sine of 2t, where the t is the time in seconds. For part A, we are asked to find the rate of change of displacement, which means we need to differentiate the function with respect to time. Since the function is a product of two terms, we use the product rule. So we have to let u equals t squared, so du over dt equals to 2t, and v equals to sine of 2t, so dv over dt equals to 2 cosine of 2t. Applying the product rule, we get dy over dt equals to t squared times 2 cosine 2t plus sine 2t times 2t. After simplifying, the rate of change of displacement is 2t squared cosine 2t plus 2t sine 2t. Now, let's move to part B, where we calculate the instantaneous rate of change at t equals pi. Substituting t equals pi into the derivative gives 2 pi squared cosine 2 pi plus 2 pi sine 2 pi. We know that cosine of 2 pi equals to 1 and sine of 2 pi equals to 0. So the expression simplifies to 2 pi squared. This value is positive, which means the beam is moving upward at that moment. In the terms of structural engineering, this indicates a high rate of displacement, which could result in increased structural stress on the beam. So now let's move on to question 5.2, highway curve radius. We are given the comfort index function as C of R equals to 50R plus 2000 over R, where R represents the radius of the curve in meters. For part A, we are required to find the radius that maximizes comfort. To do this, we first differentiate the function with respect to R. The first derivative is 50 minus 2000 over R squared. Next, we set the derivative equals to 0 to find the critical point. Solving 50 minus 2000 over R squared equals to 0 gives R squared equals to 40. Taking the square root, we get R equals to 2 square root of 10. To confirm that this value gives a maximum comfort level, we use the second derivative test. The second derivative is 4000 over R. Since this value is positive, it confirms that the comfort index is maximized at this radius. Substituting R equals to 2 square root of 10 into the comfort function gives a maximum comfort value of approximately 632.46. Using a digital graph, this maximum point is shown at R equals to 6.32 and C of R equals to 632.46.
For this part, we will explain the grafting method using the small space on the equation y is equal to 50x plus 2000 over x, which is real dimension model. The equation represents distribution by two different rates. Fact is certain. 50x show the value that increases proportionally with x, while 2000 over x represents an inverse relationship, where the value decreases as x decreases. By plotting this equation using digital we can clearly observe how the system behaves. At the beginning, the graph decreases and it reaches a turning point. After that, it increases again. To find the turning point, we apply the differentiation and set the derivative equal to 0 for the calculation. The value of n is x equal to 6.32, which is shown in the graph by the red dashed line. The black point indicates the minimum point of the curve, where the value of y is approximately 632.46. This point represents the most optimal condition in the model because it gives the lowest possible value. In other words, this means that when x equals 6.32, the system operates at maximum efficiency or minimum cost, depending on the context of the problem. So overall, differentiation helps us identify the optimal value mathematically, while the graph allows us to interpret and visualize the result through values.
My name is Nur Hanani binti Razali. My matrix number is AA250024. I will present about final answer and interpretation. Part 1. Vibrating beam. The result for the vibrating beam, we calculate the rate of change of displacement at time t equals pi. Our result shows that dy per dt equals to 2 pi square, which is approximately 19.74 unit per second. The interpretation, the positive value here is crucial. It indicates that at this specific moment, the beam is moving upwards at a high velocity. From an engineering perspective, this suggests high kinetic energy and potential structural stress. We must monitor this rapid change to prevent material fatigue over time. Part 2. Height-way curve radius. For the result of height-way curve, we identified the critical radius for the comfort index. The mathematical solution gives us r equals to 2 square root 10, which is approximately 6.32 meters. The interpretation, by applying the second derivative test, we found that d square c per dr square is greater than 0, which confirms that this point is actually a local minimum. Thank you.